Alrighty. Okay. Hello, hello, hello. Alrighty. We're back. We're back. We're back. We're back. We're back. We're back. We are back. Go. Okay. Hello, hello, hello. Sorry I got off to a late start here. Hello, everyone. Okay. Okay. Hi, Ola. Hello, everybody. How's everybody doing today? Hey, Brianna. How are you? Are you doing okay? I hope your semester's going okay. Hi, Yvonne. How are you? Hopefully, you guys are doing great. Semester's going okay. Trying to. Okay. Nice. Congratulations. There you go. You're getting a job. I'm doing great, Brianna. I'm doing, having a wonderful time. It's a good day out today. Very nice and brisk out there. But it's a good day so far. Get ready for this day to get started. That's what we got to do. We'll wait another minute or so, everyone, and we'll go ahead and get started right after that. So, maybe a few more people will come in, and then we'll be cool. Yeah, it's been a pretty, it's been a pretty interesting couple of weeks. Can't really complain so much, though. Okay. All right. I think we've had a few more people come in, so we go ahead and get started here. Okay. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, um, I want to give you a little bit of an update here. First and foremost, for everyone who's here in the chat, um, I will be posting grades this weekend. So I'll be posting grades for your first test that you took on Chapter 1 this weekend. So expect to see it at some point Friday, Saturday, or Sunday. Just need to take a look at all your work, and then I will post your grades on D2L. Okay. Secondly, uh, let's go ahead and continue moving forward here with the material. Just to understand, the next test will be over chapters 2 and 3. So chapters 2 and 3 will have material over it because they go together rather well. So last time we talked about how to divide fractions. So we did a lot of examples with that. We did some applications as well. We did multiplication division with mixed numbers. So we looked and said, okay, if you convert that into improper fractions, you should be good to go. Today we're going to look at more mixed numbers here with division and multiplication as necessary. And then we're going to do that really quickly, and then we're going to move right into chapter 3, which is talking about addition and subtraction of fractions, which is going to be the focus of today. Okay, so let's at least talk about a couple of things here that we'll need to do. So let's look at this first example here, which talks about applying some skills. This one here is a little different. So let's go ahead and read off example 3, and we'll go through this here together. Okay, so it says the local Habitat for Humanity chapter is looking for 11 contractors who will each donate 3 and a quarter days of labor to a community building project. How many days of labor will be donated in all? Okay, so I want to take a look at this one here specifically for a couple of reasons. So let's at least talk about that. I guess yes, thank you. Oh my gosh, all right. At some point, I'm going to get this. All right, there we go. All right. Okay. Okay. So in this case here, we just talked about keywords to finding in word problems that are related to multiplication and division. Now, in this particular case, if you take a look here, although it says applying division skills, in reality, this actually talks about multiplication. Now, you're probably saying, well, why is that? So let's at least acknowledge that here. So one of the keywords here in multiplication in this problem is that each person each person will donate 3 and a quarter days of labor. So every single person will donate 3 and a quarter days of labor. So they each. Okay, so if you see the word each person or each person of that variety, they're donating, in this case, that, then this basically what it means to kind of multiply here, since each person is putting in that amount. Okay, so again, you get the idea. So in this case here, let's take a look at how we can multiply here once again. So we're just going to go over just what we talked about last time. So we have 11 contractors here, and we're going to multiply that by 3 and a quarter, since each person gives 3 and a quarter days, sorry, toward this job. Now, one of the things that we discussed here last time was said, okay, 3 and a quarter here is going to be, we want to convert that into an improper fraction. So for us to do that here, remember that's going to be 3 times 4 plus 1. And we're going to put that all over 4. And as you'll get here, this is going to be 13 over 4. So here we have 11 times 13 over 4. Again, we did write 11 over 1. Now, we could see if we could simplify things down. Unfortunately for us in this case, that's not going to happen. Although you could try, but 11 unfortunately doesn't go into 4. So we're just going to multiply straight across. So if we do that out, we get 143 over 4. And then all we need to do here is to see what it is as a mixed number. So you can do the long division out if you like. It's up to you. 4 goes into 14 3 times. So that's 12. And it's 23. 4 goes into 23, not 6, 5 times. Okay, 5 times. So that's 20. So we have a remainder of 3. So our mixed number here is going to be 35 and 3/4. Okay, so that's how we get that problem to work out just fine. Okay, So that's our final answer for this problem. Okay. Any questions about that problem here? I know I went over that a little fast, but again, you'll get a little bit more practice with the homework there. So, and it's just kind of reiterating what we talked about before. So, any questions at all? Again, type no in the chat if you want me to move on, or if you have a question, please type it out in the chat. No? Okay. All right. So you did 4 into 14. The answer is yes. So 4 goes into 14 3 times. Okay, and so we got 12. And so we just subtracted there, and we got 2 left over, brought down the 3 here. You have a question, Kaka? Go ahead. As long as it's not an inappropriate one, we're okay. What is a logarithm? Logarithm is a material. What are they? Very funny. You could do it graphically, what a logarithm is. Logarithm's almost like yeah, practically like an inverse of an exponential function. Kind of works like kind of something like that. All right. Yeah, so one thing here just to note here, again, as you can see here, how we got the mixed number to work out. This is how it worked out, so we're good. Okay. All right. So 35 and 3/4. Let's go ahead and try another one, and let's see what we're working with for this next example. Okay. I'm going to leave that up there for you, Yvonne, so you can like take a look at that. Okay. Boop. All right. There we go. All right, next. All right. So let's look at example number 4 here. It says a dome tent for backpacking requires 7¼ yards of nylon material. How many tents can be made from 21¾ yards of material? Okay, so let's look at this one here. Okay, so let's talk about another keyword here for, in this case, division. Now we take a look at this last time here. Now, how do I know to use division here? So although we said in the last problem, each person contributed, X amount of days to the project, in this case, we have each of one of these dome tents is going to require 7¼ yards for material. So it says how many of something can be made from a bigger amount of something. So that's many can, insert word here. Yeah, you could literally say how many of whatever can be made or how many of something can be chosen or whatever the case may be. Now for us in this particular instance, let's go ahead and do some division here. We're going to take 21 3/4 and we're going to divide that by 7¼ All right. Now, can anybody tell me here? Let's look at 21 and 3/4. What is that as an improper fraction? Because that's what we're going to do every time. Every time we're going to switch it into an improper fraction. So can anybody tell me here, what would 21 and 3/4 be as an improper fraction? So again, we'll follow along here. Again, think about it. Remember, you're taking the 21, multiplying it by the 4, and adding the 3. And we're putting that all over 4. So can anybody tell me what we get here? 85 over 4. Good. Right? 4 times 21 is going to be 80. Well, oh wait, hang on a second. 85 over 4. Oh, one more little. 87. There you go. Yeah. I think you accidentally added 1. Nah, that's cool, Jonathan. You good, buddy. All right. You're all good, my friend. Not a problem. Yeah, 87 over 4 is correct. Okay, so that one isn't too bad. All right, and let's go ahead and erase this part here now. We're done with this. Okay, so let's do 7 1/4 as well. All right. So 7 1/4 here. Again, I'll just reiterate this one here. 7 times 4 plus 1 over 4. So this will be 29 over 4. Okay, so right now we have 87 over 4 divided by 29 over 4. Okay, how can I rewrite this problem? That's correct. Good. How can I rewrite this problem? What should I write this as? I'm doing division here, so oh, that's close. So 87 over 4 is right because we're not touching that first fraction there. Do I want to put divided by there, Yvonne? What do I have to change division to? Don't forget about that part. I also agree with the 4 over 29. That part's okay. What do I need to put right in the middle here? If I flip that second fraction over, what does that division become? Okay, very good. Nice job, Ola. That's right. So we need to change this to multiply, not keep it as divide, because that's the consequence here. All right, good. Okay, now we can see what we're working with here. As you can tell, we do have a number on the top and bottom here. We're dividing by 4 here for these two guys. That's what we have in common. So this becomes 1, and this becomes 1. And as it turns out, if you don't see it right away, and that's perfectly fine, you could get 87 over 29. That part is true. Actually make this a bit bigger here because this may be a little tough to see after all. Okay, so what you could get here is you could get this. You could get 87 over 1 times 1 over 29. And this will be 87 over 29. But if you actually do this out here, what you'll actually get is 87 divided by 29 is just straight up going to be 3. If you don't see that 29 goes into 87, that's perfectly fine. Deal with it as you would like mixed numbers there, and then you'll find out that the answer here will be 3 in this particular instance. Again, you can kind of use your calculator for that, and that should work out without too much trouble. All right, so those are a problem each of division, multiplication and division with mixed numbers. So you can see that the process is exactly the same as we've talked about the past couple of days. Again, no difference on how we're doing and approaching these types of problems. Okay. All right. Any questions about that problem there before we move forward? Okay. We'll go ahead and move on then. That's fine. Okay. All right. So today we are getting into chapter 3, which is starting to talk about adding and subtracting fractions. Okay, so we'll start with this, and of course there's more to do with just adding and subtracting fractions. We'll talk about some applications and whatnot, but we need at least get a few things down here in these particular next couple sections. All right, so let's talk about section 3.1 here. So section 3.1 here is basically adding and subtracting like fractions. Now the real question is, what are like fractions? The chapter 2 test, we're having a chapter 2 and 3 test. So we'll be combining chapters 2 and 3. So until we're done with chapter 3, we won't be having a test until then. Cool. All right. All right, so what are like fractions? All right, like fractions are pretty easy to understand. They're fractions that have the same denominator. So fractions that have the same denominator or the same bottom number, whichever way you want to call it, is basically going to be like fractions. So if we take a look here at the little handout, we can see that in example A, all of these particular fractions are like fractions because they all contain the same denominator of 4. As you can see here in letter B, these two are not like fractions because as you see here, 12 is different than 7 here. So again, these are two different denominators. Those are the only things we care about. We don't care about the numbers in the numerator. We just care about the denominator. And these are unlike fractions. Okay, so all you have to do is just look at the denominator, look at the bottom number. If they're the same, okay, like fractions. If they're not, okay, they're unlike fractions. That's perfectly fine. All right. Now let's talk about how we can add like fractions. Mostly, actually, I should say add or subtract like fractions. So how? So we'll talk about the steps to add or subtract like fractions. Okay. So what we're going to do here is we're going to make an assumption and say both the denominators and the fractions are exactly the same. Now, let's come up with a generic rule and then we'll look at examples here. Okay, so we're going to come up with the rule here first, and then we'll look at examples and see how we can work with that. Okay, so, all right. Okay, so the rule goes like this. Let's say we have A over C, okay, some fraction with two letters. And let's say we add another like fraction here that could be B over C. So notice they have the same denominator here in C. Okay, so what happens if we add these together when they're like fractions? Well, it turns out we're just going to go ahead and add the two numerators together straight up, but keep the denominator. Okay, and the same thing is going to apply for subtraction. So we have a subtraction here. We do B over C. And so we subtract straight across for the numerators, but keep the denominator. Okay. Go ahead and put that down. There we go. All right. So that's the two rules here for, again, adding or subtracting like fractions. So let's go over the steps here, and then let's talk about steps here. So there are steps for sure. All right, so let's talk about them in a little bit more detail so we can reflect the rule that we have here. Okay. All right, so step one. Step one is to confirm that all the fractions have the same denominator. So you're just making sure that you have the same denominator so you can actually employ the process. We'll talk about how we can adjust with that a little bit later, when they're different, that is. Okay, next, step two is add or subtract the numerators, okay? Add or subtract the numerators straight across, okay? And put the result, and keep, I guess I should say, and keep the same denominator. So notice in the denominator here, notice I put this in kind of capital letters. The reason why is because you're not subtracting the denominators, adding or subtracting the denominators. You're only adding or subtracting the numerators there. And that's it. Okay, and then you'll keep that in the same numerator. Finally, for step three is to reduce as necessary. Okay, so sometimes you'll need to reduce just based on the problem. We go ahead and just see if we can divide out something in the numerator and denominators, the common factor, reduce it down. Okay, we got it. Okay, so let's look at some problems here. All right, and let's go ahead and met them out. Okay, see what we're working with. All right. Okay. So let's work with this first example. Actually, I should have put that. Yeah, that was it. Okay. Okay, so let's do 1/5 plus 2/5. Okay, so 1/5 plus 2/5. All right, so just to show this off here, 1/5 plus 2/5, all we're going to do is just add up the numerators together. We'll put it just here on the top, so we'll have 1 plus 2 here on the top, but we'll just keep the denominator here the same, which is 5. So I'm just going to leave the denominator, but just add or subtract depending on what operator we have. Just going to add in this case. So in this case here, we get straight up 3/5. Okay. So 3/5 is our final answer for that. Okay. Let's look at that next example there on the handout. I'll go ahead and write it out here. Okay. So let's take a look at this one here. So what should we do here in this problem if we're going to solve for this fraction? What should we do? Okay, that's right. Over 12, good. 1 plus 7 plus 1 over 12. Very nice, that is correct. All right, so we have 1 plus 7 plus 1, so that's 9 over 12. Okay. Does this fraction reduce? Can we reduce this fraction? That's the last step there. 3/4, that's correct. That's right. So it has a common factor here between 9 and 12, and that factor here is 3. So I'm going to divide by 3 here. Remember, you have to check if it can reduce. So the homework problems will expect you to reduce the fraction. Okay, so all right, so 3/4 is the final answer for this problem. Okay, very good. Let's I wonder if they did that. Let's check that. Okay, let's look at another one here. This time, let's talk about subtraction here. Let's do a couple subtraction ones. Okay, so 7 over 10 minus 3 over 10. So 7 over 10 minus 3 over 10. So we're not going to do anything different like we did in the last problem. We're just going to go ahead and this time just subtract straight across for the numerator and keep the denominator the same. So we get 7 minus 3 over 10, which will be 4 over 10. And 4 over 10, does that reduce? Does 4 over 10 reduce? And that's the question we have to ask ourselves at the end of every problem. Does the resulting fraction reduce? And to what, if it does? What's that going to be? Yeah, let's divide by 2. Sounds like a plan. That's right. Good. So here we get 2 over 5. Nice. Good. Okay, so that's our final answer for that one. Good. Let's do another. Let's go ahead and do another here with the subtraction, that is. Yeah. Okay. So this is our 3 fractions here. So 9 over 20 minus 3 over 20 minus 1 over 20. Okay, uh, so let's take a look at this one here. We're going to subtract 9, 3, and 1. We'll keep the 20 since it's all the same. Okay, and what do we get here in this case? What's our final result here? That's our final result here for this fractional problem. One third. Okay, let's take a look. A 1/4. Okay, let's take a look. So we get 9 minus 3, which is 6. 6 minus 1, which is 5. 5 over 20, that does indeed reduce. We divide by 5, which is correct. Very good. And good adjustment there, Yvonne. You got 1 over 4 here. Nice work. Okay, good stuff. Nice job. All right, questions about that so far? Any questions? No? Okay. All right. So as you can see here, adding and subtracting of fractions is not hard at the very least in terms of just straightforward problems like that. Now there are another couple types here of problems that you may encounter. So let's at least talk about those. And those are if we happen to either add or subtract and we want to express that answer in a mixed number form. So I'm going to do a couple of examples in relation to that. So let's go ahead and do that right now. So we'll follow the same process here. The only last part here is we have to change it to a mixed number if it's necessary. So I'll show off a couple of examples. So for example here, if we have 19 over 6 minus, let's say, I don't know, I'll call it 5, 6. 5, 6? No, no, 5, 6. 6, 7. Yeah, 7 is fine. 7, 8. Ooh, I tried to fix the one. That's a pretty hard one there. I picked the right one so I get a good answer. uh, I'm like, isn't there a number that goes with this? Be like, sure, why not? All right, we'll go with 2 over 6, even though this looks a little silly. Uh, so we're gonna do 19 minus 2. Put that all over 6. We're gonna get 17 over 6. And then it'll ask you, okay, put this as a mixed number. So the mixed number here would be, again, the same exact process. Find out how many times 6 goes into 17. That happens to be 2 times. So that'll be 12. And then we would have a remainder of 5. So our final answer here for this guy would be 2 and 5/6 once you convert it over. And the same thing goes for addition as well. So let's just take a look at one of those, and then we'll go ahead and move on here. All right, so for addition here, we're going to go ahead and take, again, let's take 7/9 and add it to, let's say, 15 over 9. So this would be 7 plus 15, all over 9. Or again, 22 over 9. And if you do this out here, again, 9 goes into 22, in this case here, 2 times, which is 18. Subtract that, we get 4, remainder 4 left over. So our final answer here is 2 and 4/9. Okay, so just some quick, couple of quick examples there, just to kind of show off. Yeah, we may need to convert back into mixed numbers there after we add or subtract, depending on what they want. All right, so that by far and away isn't too hard. Again, rather straightforward. It just combines some of the things that we learned from the last chapter into this chapter. So this is why I've kind of integrated both because, as you see, they have a lot to do with each other. Okay. All right. Let's look at the next section here. All right. All righty. So the next section here is going to be very important in terms of adding or subtracting. Unlike, yes, go ahead. What will the question ask on the test? So it'll be like the homework. It may ask you to be um, like if enter your answer as a mixed number. It's the stuff written in blue there. It says it could be written as an improper fraction or a mixed number. Just depends on what each question asks on MyMathLab. So again, just be sure you know what format that will be entailed in. Okay. As you know, if you tried the homework there, you know that the MyMathLab is a little particular about how it likes some answers. So I just want you to be aware about that. Am I going to a practice test? Absolutely. I always do. Yeah, you're definitely going to practice test just like the last one, for sure. 100%. I think a lot of people like. I don't know if you guys like the practice test or not, but I think it's very useful into getting you like comfortable and familiar with what the test is going to look like. As you probably saw, you saw that the questions were on the test were probably very similar to the ones on the practice test. So yeah, I designed it that way so it's like okay, you know exactly what you were expecting. You know, I hope it made it easier for you, Jonathan. I really do. So that was the whole point of the practice test there. All right. Well, let's go ahead and move on here. All right. Let's do the next section here. All right, some of these sections will go faster in this chapter. Some will go slower. All right, so we'll need to do that. All right. Okay. Now this next section here is very, very important. And this talks about the least common multiples. All right. Now let's talk about the least common multiple between numbers here. And this is going to be very important in determining how to add or subtract fractions in the very next section. So at least we need an understanding about how least common multiples work. Now, least common multiples are basically called again, you may see this written as LCM for short. Okay. While all that's nice and fancy, what is a least common multiple? All right. So the LCM here, the least common multiple, in terms of a definition, is the smallest multiple in common between all the indicated numbers. Okay. So the smallest multiple in common between all the indicated numbers. All right. Now I'm going to put here the smallest multiple in common between all the indicated numbers. So let's at least underline that. That's very important there, certainly. Now I'm going to make a very important note, and I'm going to reiterate this note here. Okay, and this is actually, in my estimation, going to make your life significantly easier when you add or subtract fractions. So I'll state it here, but then I'm also going to state it here for the next section as well. Okay. So one of the things about this is that oftentimes in this concept, you often get confused about what the least common multiple is. Let me give you a little check here, okay? So I'll show you what I'm talking about here, and then I'll add the note in. Let's say I want to find the least common multiple, and I know we haven't really done any examples here, but let's say I want to find the least common multiple of 2 and 8. So what do you think is the least common multiple of 2 and 8? What do you think that's going to be? The least common multiple between 2 and, of 2 and 8. Okay, Ola says 2. All right. Anybody else? Besides 2? Okay, get 2 for Yvonne. All right. Anybody else? Again, put in your answers there. So, this one here is an important question. So, again, I would like to hear your answers to this. What do you think the least common multiple of 2 and 8 is? All right. Some people not talkative today. That's okay. We'll just take a look here, at least in this case. Okay. So let's go ahead and take a look here. Now the answer to this one here is the least common multiple between 2 and 8 is 8 and not 2. Now for some of you thinking that this was 2, that answer is actually incorrect. The least common multiple here is definitely 8. Now you're probably saying, whoa, 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 timeout. Why is it 8 and not 2? Well, let's at least talk about the psychology behind this here. The psychology behind this is that the first thing that you see is the letter L. All right, and that represents the word least. And when you think of the word least, you think of the word smallest. And when you think of the word smallest, you pick the smallest number. That's what the psychology pretty much says. So what we're going to do here is we're going to essentially, we're going to make a little bit of a change here. All right. It is the smallest multiple here, but I'm just going to kind of strike this out. And you can strike that out too. It's a multiple in common between all the indicated numbers. Yes, it is the smallest one, that's true, but this is where this note is going to be very helpful. So the big key note here in this particular case is that the least common multiple between numbers is always the biggest number or higher. This is always true for the least common multiple. Okay. So again, the least common multiple here is always the biggest number or higher. So you should always, if I give you 2 and 8, for example, you should start at 8 and then find multiples of 8. And then see if that works with the other numbers below it. So it's actually in reverse than what you're actually thinking about. Okay? So this is going to be incredibly important because this helps us out in determining how we can add or subtract fractions when we want to find like common denominators. Okay, so we have that in that case. Let's look at another example. Okay, let's look at an example here. Remember, it's always the biggest number or higher. Okay, so be sure you make a note of that. All right, be sure you make a note of that. That's always the biggest number or higher. Let's try another one here. Let's try, here we go. The common multiple of 6 and 9. So the smallest said 1, so in any case. Okay, so what's this going to be? Least common multiple between 6 and 9, what's that going to be? Nine? So the question here, Hannah, is does 6 divide 9? So you could try 9 first. So 9 is a good start there. But does 6 divide 9? That's okay. 12, again, remember here, you always start at the biggest number or higher. So start at 9. Do not start at 6. Start at 9. That's what the note here is there for. This is one of the, I guess I'll even put in, it's a keynote here because of how important that guy is into determining this. So start at 9 and make a little list. You say, okay, I got 9. Well, 9 obviously divides itself. That's fine. 6 does not divide 9. So I go to the next one up, plus 9. I go with 18. I say, does 18, so 9 divides 18? Yes. Does 6 divide 18? Does 6 divide 18? Yes or no? Yes. So since 6 and 9 both divide 18 here, your least common multiple here will be 18. And that'll be your answer for that problem. Yeah. That's why I put the key note there, because this removes that confusion about saying the word, smallest or least necessarily. It's now choose the biggest number, let's look at multiples. And which, in that case there. Okay, let's try another. Let's try okay. Let's try 4 and 10. So let's try 4 and 10. will be that common multiple there between 4 and 10? All right. Yes, that is correct. Okay, good, good, good. All right, so you try 10. That's where you start from. You're like, okay, 4 doesn't divide 10. Too bad, so sad. So we try the next one up, 20. And 4 does indeed divide 20. 10 definitely divides 20. So our guy here is 20. Okay, let's try another one. This time, though, I'm going to take it a little bit further here. They have different ones here. There we go. All right. Let's say we're given this one. So this one, we're going to look at several different ways to do this example here of 5, 6, and 35. Okay, so we're going to look at slightly a few different ways here, but let's look at 5, 6, and 35. Okay, so 5, 6, and 35. We want to find that common multiple there between all three numbers. So that number has, all three of those numbers has to divide our common multiple there. So this may take a few tries here, which is perfectly fine. Okay, it may take a few multiples, but that's fine. Again, if you're not sure, you can try it out with the calculator there and whatnot. Yes, that's true, Civil. That'll be the second way we'll show here. But just doing it the old-fashioned way of reducing confusion. Your math teachers are all 100 years old. Sorry about that. I don't know what to tell you there. I'm not 100. 210. Okay. 210. All right. All right. Let's take a look here. All right. We can probably definitely agree to this. All right. So let's see here. We have 35. Now, unfortunately for 35, yeah, 6 doesn't divide 35, even though 5 does. So that's out. 70. Again, 35 and 5 certainly divide 70, but unfortunately 6 does not. So that's a bummer. Next one here would be 105. And again, 5 and 35 are good to go, but sadly enough, not 6. 6 is a kind of a roadblock in our way here. Next, we have 140. Again, 140, 6 once again being our roadblock. 175, same thing. Unfortunately, 6 is a no-go. But we get 210, and now 6 definitely divides 210. So that's correct. The answer here is 210. That will be the smallest said multiple here in this particular case. Okay, we're going to look at another way to do this here, and exactly as Civil has said here. Again, we'll use prime numbers of which to do that. But before we get started with that, are there any questions about at least the answer here, how we found it using this method at least? No? Okay. Drink the last of this stuff here. Tastes like victory. Ooh, protein shake is good shake. All right. Yum, yum. All right. All right. So let's take a look here and see if we can replicate the 210 here. All right. Using, in this case, as Civil has says, using prime numbers. Okay. Now for us to do that here, let's go ahead and make remember, if you recall here what we did back in chapter 2, or actually maybe it was chapter 1, we did the factor tree there. So we're going to revisit the factor trees that we talked about here in chapter 1, and we're going to work with that here in this case. So let's take a look at that. Okay, so let's take our three numbers here. So let's do it the prime factoring way. So we have uh, we're going to have 5 and 36 and 5, 6, and 35, I should say. So we have 5, we have 6, and actually, let's do it that way. Okay, 5, 6, and 35. So we're going to break down each one of these numbers here appropriately into their prime factors. Okay, so let's go ahead and put that in the document here. So second method. Okay, so we're going to break it up into prime factors and quote unquote pair off any matches. And let's talk about what that part means. So let's at least discuss that here. Okay, I'm going to make this a little small. There we go. Okay, so 5 here is a prime number by itself. Okay, so unfortunately we can't break down 5 into any other prime numbers. So we're just going to circle this prime number just like so. And we'll come back to this 5 here a little bit later. 6 here can be broken down into two prime numbers. That's going to be 2 times 3 or 3 times 2, whichever way. And we're going to go ahead and circle those because those are the prime factors there. And then 35 here will be 7 times 5. Okay, so we'll go 7 times 5. And those two are prime numbers as well. Now we're going to make a little list here in order to get this second method done. So we have 5. 5 here, the only way we can get 5 here is equal to just itself, 5. 6. 6 here is equal to 2 times 3. And we have 35 here, which is equal to 5 times 7. Okay, so now that we have that, we're going to go ahead and pair off any matches. Any two numbers that match in this list of numbers, the 5, 2, 3, 5, and 7, we're going to go ahead and quote-unquote pair off. Now, what does that exactly mean in this case? So to pair off means that once we circle a pair of numbers, and let's go ahead. A pair of numbers, we only include one number. We only include one number in the least common multiple. So if I were to circle 5 and 5, okay, so if I want to find the least common multiple here, I'm just going to take 1, 5, because I've effectively paired off 1, 5 here. So I'm just going to write 5. And if I see if I have any other pairs per se, then I would circle those together and I would just include one of those numbers. Now what I'm going to do next is I'm going to go ahead and multiply by, again, the rest of the numbers here, okay? Anything that's single, we'll go ahead and put those in, so 2 and 3 and 7. And then if you multiply that straight up, you in fact will end up with 210, okay, which is our answer here in this case. All right, so there we go, move that up there. All right. Okay, are there any questions about that? We're going to do another example, but I just want to be sure that that made sense, at least to how we found 210. Everybody good? All right, we'll move to the next one then. That's okay. Let's go ahead and give it a go. All right. All right, let's look at the very next one here. The very next one here is 10, 20, and 24. So 10, 20, and 24. Let's say we have to find the least common multiple between all of those. So let's go back to our little example here. So 10, 20, and 24. Okay, let's break down 10. All right, let's break down 10. What does 10 break down to? What does 10 break down into? We broke it down into its factors there. 5 and 2. Okay, sounds good. Perfect. All right, so we'll circle the 5 and the 2 here. All right, how about 20? How about 20? 4 and 5. Okay, I agree. 4 and 5. And again, we can break down the 4 here. Again, that can be 2 and 2. So don't forget, we want these prime factors here for sure. All right, how about 24? 6 and 4, okay. And what do those break down into? All right, 3 and 2, agreed. And 2 and 2, nice job. That's right. Okay, so let's break this down here exactly as we have. So we're going to write 10. 10 is 2 times 5. Okay. 20. 20 is equal to 2 times 2 times 5. Okay, so just written out with their prime factors there. And 24 here is equal to, in this case, let's see, 2 times 2 times 2 times 3. Okay, so that's what we have here for this problem. Okay, now let's start off pairing numbers together to get our least common multiple here. Okay. All right, so how is pairing going to work here in this case? Well, as you can see here, I put pair in quotations. And the particular reason why I put pair in quotations is because a pair usually means two things that are the same. But I put it in quotations because what we can do also is take, say, a three of a kind as well. So 3 of a kind here is acceptable here. Okay. So that can take care of 1, 2 there. So I'll put a note here for this. Note 3 of a kind is acceptable for a pair. Okay. So it's a little different here, I know, but that's why I put it in quotations. So you can understand that, yeah, we're taking the 2 out, but we're still considering that a pair of some variety. Now we have a few more pairs here. We got 2 5s, so we're going to pair that off. And we have 2 2s here. So we're going to pair that off. And then we have the rest of it, which is 2 and 3. So if we do this out, we multiply all this together. So 2 times 5 times 2 times 2 times 3. And if you do that out, that will be exactly 120. And that will be your final answer for this problem. Any questions about that? Yeah. So, all right. Okay. Okay. That is, yeah, we're going to do that. But, all right. No, sir, says, all right. Okay, good. All right, so that is where I am going to stop there for today. So for next time, we're going to finish up this section here in talking about rewriting with the indicated denominator. Really, we're going to be doing that anyway in section 3.3, so I may just end up skipping that part and going right to 3.3 because we're going to see exactly how it's going to work with the common denominators and whatnot. So if you're used to, well, thank you, Paddix. I really appreciate that. So if you're used to that there, then that's fine. Homework here, again, we did finish 2.8, 3.1, and 3.2. Okay, that's those are the 3 sections we covered here today. So we're going to talk about how to add fractions here for add and subtract fractions here for next time. So we're going to be using these 2 concepts here in terms of finding the least common multiple, which will turn into the common denominator, and being able to start putting together the pieces of algebra. Okay, this is like the first big piece of algebra, really. So we're going to look at that first big piece of algebra here, and hopefully it'll be a lot easier to do once we get that piece slotted in. So this is going to next week here will be a pretty big week for us in terms of just starting to get the beginning throes of understanding this subject a lot more. Okay, so some bigger plans ahead, that's for sure. Uh, are there any questions? Any other questions? You guys can ask me any questions you like. Oh, thank you, Paddix. You're from Morocco. Oh, that's awesome. Must be nice over there right now. Thank you, Paddix. If you have any questions, feel free to come on by anytime. You're always welcome. All right. No questions? All right, that's perfectly fine. Okay, so we're gonna leave it off here for today. All right, I want to thank everybody once again for coming out to the stream. Thank you, Paddix, for the very nice words. I hope you enjoy everybody. I hope everybody here enjoys the rest of your day and your weekend, of course. All right. Um, please take care of yourselves. All right. And I will see you all on Tuesday. Okay. On Tuesday for our next class. Otherwise, if you're here for the 11 o'clock class, I will be back in 10 minutes. Okay. All right, everybody. You take care. All right. Have yourself a great one. All right. Again, email me if you have questions. All right. Thanks. All right. Have a great one, everybody. See you later. All right. Bye.